Welcome, everyone. How is everyone feeling about the world's best developer conference so far? Great? Yeah, I think we should give them all a big applaud. Excellent. I love this conference. I love coming here. It's not too far. I'm from Gothenburg, so it's not really far to travel. So did anyone come here to listen about VB? That's good. I have a few things to say about VB, but let's keep that for later. We're going to talk a little bit about the state of C#. So C# has changed a lot over the past few years, or the past 10 years. So we're going to cover a lot of the features that you've missed. We're going to talk about things that might be coming in the next versions, things that Microsoft have been talking about adding to the language for a long time that they didn't. So we'll talk a little bit about why they might not have added that. All right, so is everyone in here a C# developer? If you're not, raise your hand. Huh? Gotcha. All right, so my name is Filip Ekberg. I'm a Microsoft MVP. It means that I talk about Microsoft stuff, but I'm not really employed by Microsoft. So kind of free marketing. So I wrote a book called C# Smorgasbord that's available for free on my blog. So just head over to my blog and download that if you want. It's been out for a few years. I cover a few language features like async and dynamic and how to write good code. All right, so enough about me and about my book. We're going to talk about the best language in the world, which is C#. So C# is kind of this mix of all the different paradigms out there. We have declarative programming languages, imperative programming languages, and functional programming languages. And C# tries to steal all features from all of them, or borrow, I don't know, whichever makes you feel good. So they take things from F#, and they take things from Kotlin and Swift and Java and all those different other languages out there and kind of make that as a part of the C# experience. And I think that's what makes C# one of the best languages out there. And if we just go back over the years, I want to quickly recap some of the things that was added to C# after the first version. So C#1, we got if statements and switches and for loops and whatever all the other normal programming languages at that time had, right? So, but after that release, we kind of got C# 2.0, which added generics and partial types and anonymous methods, iterators and nullable types, and so forth. So this was kind of heaven for developers because I came from a Java background, and having worked in Java, coming to C# and do generic programming was really great. It was one of the things that kind of made me stick to C#. All right, so this was a great addition to the language, but the next addition to C#, which was C# 3, we got implicitly typed local variables. And a funny story here is that when they introduced this in the language, I've had this discussion so many times with developers over the years, they thought that just because you didn't add the type at the start, C# was now a dynamic programming language. Which is not kind of the thing, right? So just being able to write var x is equal to 10 doesn't mean that it's dynamically typed. So it took a few years before, well, maybe a few months before people got that after C# 3 was released. And then we got auto property initializers, anonymous methods, extension methods, and query expressions, and so forth. And things that kind of led up to us being in this more functional environment. We can now write link expressions, and we can do all types of craziness that kind of builds up this language into being even more expressive than it was before. Things like generics in C# 2 came from research at Microsoft when they did that for F#. So they took those bits and added that into C#, and kind of the same goes for the features that they added in C# 3, which they kind of took from other places as well. So they all kind of take these different ideas from each other and add those to the languages. We're not going to spend too much time talking about the old versions because everyone in here probably knows a little bit about all these different features. Now, something interesting happened with C# 4. We only got a handful of nice features. Now, I'm not trying to say that the team didn't work well on adding things to the language, but I mean, come on, what, 3 features? I want this huge list of things added to the programming language. That's why I choose C#. So we got dynamic binding. So finally, we were able to write dynamic programming in C#, which meant that we could now do things like Iron Python and Iron JS, and we could write things in a more dynamic manner. We could write scripting in our applications and have that evaluated at runtime. That's pretty cool. And then we got C# 5 with only pretty much one feature. I love async. It's one of those things that's been keeping me employed for the past few years because everyone gets it wrong, and I need to go in and help them understand asynchronous programming. So I think it's great that they add asynchronous methods to C#, but they've made it so easy for developers to add async code that they kind of forgot about how hard it is to write asynchronous programming. So if we look at these different iterations of the programming language, the second iteration, we got a lot of features. The third, we got a lot of features. Then we got less, and then we got less. You'd expect that C#6 added just like a handful of features. The problem here is that by this time, the compiler was probably, 8, 10, 12 years old, 13 years old, and written in C++. I don't know if anyone in here has worked on a 10-plus-year-old project written in C++. Can't really be one. Awesome. Oh, actually a lot. That's awesome. So you probably know that it's hard to maintain those apps. And adding new things to those that kind of fundamentally changed behavior, they need to do a lot of things in the compiler to make asynchronous methods work, right? So that kind of makes it difficult. So at this point, they had already announced that they were rewriting all the compilers. So does anyone not know what Roslyn is? A few of you don't know what Roslyn is. So Roslyn is this project that Microsoft called it. It's really the Microsoft .NET compiler platform. So what they did was they took the compilers, they looked at it and felt like, we need to rewrite this in something better than C++. So they rewrote the C# compiler in C#, which is pretty cool. So they used the old compiler to compile the new compiler. Now, what do you do with bugs in the old compiler? Do you bring them across to the new compiler as well? You probably have to, because it needs to be able to compile old apps. And if you break old apps, that means that the compiler is not really that good, right? So they had to re-implement all the bugs in the old compiler, which probably feels horrible to a developer, knowingly adding bugs to your code. But that's what they had to do. So they started rebuilding the compilers, which is Roslyn. The idea here is that they can now add more language features a lot more easily. So how do we make it even more easier for us to add features to the language? One of the problems that Java had over the years is that they had this language design team that was sitting in a cave somewhere talking about features they wanted to add to the language 10 years in the future. They didn't talk to anyone else until they released that version of Java. That's kind of problematic and not very agile, right? So what Microsoft did was that they released the compilers as an open source project. So if you go to GitHub, you go to .NET/Roslyn, you can see here that there's 35,000 or 36,000 commits to the .NET compilers, or the Roslyn compiler. So this compiles both C# and VB. It does all the code analysis. So what you can do with this is that you can bring that into your application, and you can point to a C# file and have that compiled by your app. This means that you can get scripting with C#, and you can do all kinds of crazy things with the compiler. Now, they've done 91 releases. You know, there's not 91 releases of Visual Studio. That would be crazy, right? But what you can do is that you can go into the releases here. You can download a version of the compiler and just bring that into Visual Studio. Or use that as a NuGet package in your app and write your own IDE, for instance. I think that's pretty cool. And working in an open source environment means that we don't only want the code out there. So I think Apple has done kind of open source for a long time, but the way they do it is that they develop everything internally and then just publish the code, which is kind of the wrong approach as well. So you'll see here there's 4,700 issues. I wouldn't want to be the PM that has to arrange all those different issues and prioritize. But a lot of people spend time adding issues to the compiler or adding feature requests, adding bugs to reporting bugs here, which is great. So this kind of opens up for this dialogue with other developers. All right, so and they have a lot of pull requests. I've actually done a pull request to the compiler GitHub repository, so my face is in there. I updated a spelling mistake in a document. So yay for that. I didn't get anything, though, so oh well. What they also do is that they post all their C# design guidelines, or their C# design notes. So Matt, that did the keynote this morning, he's posting a lot of the internal discussions they have here. So when they're at Microsoft, they talk about the language features and they add their meeting notes to GitHub. People can pitch in and talk about ideas on features that they want added to the programming language. And I think this is a great way for the language to evolve. But it also means that there's so much noise from the community about features that we might want to have in the programming language. Here's an example. So in C#7, we got tuples, or better tuples, language support for tuples, rather. And this proposal was up already in 2015, and they just added that a few releases ago to the C# compilers. So they talk about why they want to add this. They have a lot of mathematical information about how to implement this and the implications to the programming language. And people spend so much time talking about the language features, which is great, because it helps us as developers. We don't have to worry too much about that. So introducing Roslyn, opening up for other people to write things in the compiler and for Microsoft to work with this openly, means that they can now add features to all the different programming languages a lot quicker. This means that we want to add features to a language that most people kind of leverage, which is C#. So that means there's no more language parity. Previously, what happened was that we have a feature in C#, and it's also available most of the times in VB. If it's in VB, it's probably in C#. There's very few things in VB that I would like to have in C#, except the XML literals. But they've always been the parity between these languages. But that's not the case anymore. So what happens now is that they might add things like pattern matching to C#, which is not available in VB yet. But there's still a ton of VB developers out there. So they will probably add that, who knows, in the future. So now, we've kind of come to the point where we're going to talk about pretty much the current state. Is anyone in here not familiar with C#6? Most of you are familiar with C#6. It was released a while ago. So we'll quickly go through these different language features and just have a look at the different ones. I have features listed for all the different C# iterations. And we'll jump into Visual Studio and have a look at them and talk through these different features. And if you have any questions, just throw something at me. Not your laptop, because that hurts. So we got using statements for static members, which means that we can now be we can use less characters when we use a lot of static types. We got auto property initializers. The idea here is that we can now use proper read-only auto properties. Previously, it was really hard for us to introduce an auto property that you only set once during your application. Right? We can do awaits inside catch and finally blocks. We got the null conditional operator. That's probably one of the best features in C#6. String interpolation, that's really handy. We no longer have to do string.format. Just does that underneath for us. Dictionary initializers, we got expression-bodied members, and exception filters, and as well as the name of operator. Like this list here, that's why I choose C#, right? Because they add all these different language features that help me save characters. So, does everyone in here know who Scott Hanselman is? He did a joke once, I don't know if it was a joke, but he said that we only have a certain amount of keystrokes in our lives. And I think that the C# team, they can spend as many keystrokes as they want, as long as I don't have to spend them, right? So if I can save up a few characters when I write my C# code, that's really great. So we have this solution here. I have language features from all different versions of C#, and we'll go through all of them. So the first one is using statements for static members. It's super simple. We'll go through them quickly. What we do here is that I no longer have to say console.writeLine. At the top here, I can say, well, I want to use all the static members from this class. I could do the same thing for math, for instance. I could say using static system.math. And I would then be able to say pi instead of doing math.pi. And of course, if I introduce a method in here, in this context called writeLine that takes the same parameter, that one wins instead of console.writeLine, which makes sense. So it's the same resolution as they've done before. And we also see the namef operator here, which is kind of a great addition. What they do here is that they simply allow us to say, well, you have this type here. I want to get the name of that type. And why is that important? Because far too often in error messages, you've forgotten to refactor the name inside the error message of the type that was a problem. So this here will allow us to, when we refactor program to something else, it'll just reflect on all the different places. And we're also seeing that we're doing string interpolation here. So previously, we've been able to do an @ sign here to allow us to do certain things inside the string. But now we can do this $, which is allowing us to say, well, inside these curly braces here, I'm going to have something that evaluates as a code block. So we could say 10 here, for instance, or we could say var x is equal to 10. And we could say x in here, right? Super simple. So we no longer have to worry about that string.format and the order of things when we're doing string.format. All right, so the auto property initializers, which is the next cool feature. In this case here, I've got this string property called name here, and I'm setting that to the initial value of Filip. So this here is a true read-only auto property. If I try to set that down here, it'll tell us that this here is actually read-only, so you can't do that. So that's kind of a nice addition. Now, one of the things I really love about C# is how easy it is for us to do asynchronous code. But one of the problems prior to C#6 was that we couldn't do awaits inside catches and finally blocks. So very often you want to clean up after yourself or add something to a database and do that asynchronously. And you couldn't do that before. So in this case here, I have this run async block here. It catches an exception, and then inside the exception, I want to clean up, and then maybe I want to dispatch a message somewhere, and so forth, right? But of course, then what happens is, well, if this throws here, you would probably have to have that as an inside a catch block as well, and you would just end up in this mess. But it's nice that it's there. Now, probably one of the best features added to C#6 is the null conditional operators. So one of the things they're working heavily on, both in C#6 and C#7 and 8, and probably 9 and 10 as well, is that they want to avoid us having null reference exceptions. Now, adding null to a language is probably one of the worst design decisions ever, because I don't know, everyone in here probably got a null reference exception sometime. Languages like Kotlin and Swift, everything is not nullable, not null by default, which means that you have to be very explicit when something can be null, which means that it's really hard for the application to just suddenly throw a null reference exception. Those languages do other weird things. Anyways, so what we can do here is that I have this array of person here. It's null because it's not initialized. We can just imagine that it's retrieved from somewhere. I can say here, well, I want to grab other people. And if this array is not null, I want you to give me the first item in the list of people. If that's not null, I want you to give me the name of that person. What happens here is that if one of these things are null, when we're doing this null conditional operator, this entire block here evaluates to null itself. So then we can use this thing here to say, well, if any of these are null, we'll just default to this value, which is kind of nice. All right? And you'll see here the same at the bottom here. We say, well, if person is not null, give me the name. If any of that is null, just say unknown. If the person is not null, give me the address. If the address is not null, give me the street. It's pretty simple. Now, in reality, your code now looks like it's question marks everywhere and that you don't know what you want. So it's a trade-off, right? So expression-bodied members, it's one of those additions that kind of didn't make sense to me from the start, but the more I use it, the more I like it. In this case here at the bottom, I'm overriding toString, and I'm simply saying, well, I want to return something. So instead of me having to write a lot of code to do that, whoops. So instead of me having to write the method body here, which would be return name, right? I can just do that expression body member. It's less characters. That's all that matters. Right? Looks pretty nice. Super simple addition. And then finally, the language feature I want to talk about is exception filters. So with exceptions, you know, when you want to catch an exception, you want to say, well, I want to catch the network operation timed out exception, only when the status code or whatever I'm looking at is something. What you had to do previously was to say, well, I want to catch that exception and then have an if block inside that, which kind of ended up being a little bit nasty. So now we can say, well, I want to create a new HTTP client. I want to do this call to google.com. When I get a web exception and the web exception status is timeout, I'm going to retry. But if the name resolution fails, well, that means that I don't have internet connection, for instance. It means that I can't do a DNS check. Right? So this is kind of nice. And you'll see later that they've reused the when keyword in other places. All right, so let's just head back to and talk a little bit about C#7. So C#6 added a lot of nice features, and that's kind of one of the powers of Roslyn. They had really easy, it was really easy for them to add features to the language, especially now that the compilers were rewritten. So what is there in C# that's missing? A lot of things. For instance, tuples and deconstruction. I don't know if anyone in here has worked in other programming languages where tuples is kind of a first-class citizen. It's one of those things that just makes sense when you have it in your code. It makes things like pattern matching a lot easier, and it makes the code look a lot more beautiful, which is kind of what we want. So they also added pattern matching, or a first attempt to pattern matching. There's a heap of improvements coming to the pattern matching stuff, but at least it's in there. Digit separators and binary literals, local functions, that's pretty cool as well. Ref returns, they did some improvements to the out parameter. So these aren't kind of a heap of features, but things like tuples and pattern matching, that's no easy thing to solve. So it probably took a long time to add that to the language. So let's look at the code for this. So we're past C#6, we're going to look at tuples. This is a tuple. Pretty much multiple return types. Or a way for us to express ourselves and say, well, I have this thing here, just create the type for me. So we have these two things, two integers that I want to return from my get point here, and I return 100 and 200. That's automatically injected into the x and to the y. Okay, that's pretty cool. So when I use that, I can kind of deconstruct that in different ways as well. So I can say, I want to get the point. I want to map the tuple that we got from get point here into these two different local parameters. But I could also say, well, I want you to map those just automatically and see that the code here still works. Doesn't show up anything. Because what happens is that we can say point.x and point.y. And of course, if we just undo that, I could say point x and point y, and now the application doesn't work anymore because I've deconstructed that into two different local parameters with two different names, as you see at the bottom as well. So this kind of helps us when it comes to pattern matching, and you'll see why when we talk a little bit more about C#8. So this is kind of one of those things that they add to the language because it's going to be nice along the way. It's something that they need to have in the language in order for them to add more cool things. All right, so that's tuples. Super simple. Really, what they do is that they map to, I think you can cast that to a tuple as well. And this here will allow you to do item 1 and item 2 as well under the hood. So they do a bit of magic there as well. So if it works with the old tuples, that is. All right, so pattern matching is one of those things that's kind of hard sometimes to get your head around. The idea is that, in this case here, I have an abstract class called shape, I have a triangle and a rectangle, and I know that inside my program somewhere, I get this thing called a shape. I don't know which shape it is. I don't know if it's a rectangle, a circle, or a triangle. So I want to say, well, depending on the type, give me the correct type and give me that as a local parameter without me having to cast anything anywhere. So what we do is that, well, I'm going to create a new shape here. You see that this is a type shape. I use the switch block and say, well, when this is a triangle, give me that as a local variable t here. So that means in this context in here, I can use all the properties that I have on my triangle. And down here at the rectangle, if it's a rectangle, I get that as well. right? So that's pretty neat. And one of the places we use this in other languages, so I'm doing a bit of Kotlin at the moment, and they do pattern matching everywhere. One of the ways that we can do this is by saying, well, I do a call to our web server, and the result is then transformed into the correct object or into an error. So I can say, well, if it's either the error or if it's the correct data container, I know what to do in my app. So you can do pattern matching to find out kind of where to go in your app as well. So I think it's super powerful. Local functions and binary literals, I don't know if I'm ever going to use this. So the digit separators allows us to just add a lot of underscores everywhere. I don't know why I would do that. I don't really write numbers like this. If I want to write the number 16, I just do this. So, I mean, I guess if you're a game developer or you want to impress on someone, I don't know. All right, so local functions. I have this function called calculate down here, which is an internal or local function called Fibonacci. So this returns the Fibonacci of x. And this is kind of nice if you want to have a, you don't want to leak something out to an outer method, or if you just want to decompress something, or you want to do something very specific in that context. I think it's pretty cool. I haven't really used it yet, though. Again, if you're a game developer, you probably do a lot of refs and out parameters, and you want to optimize all the different types and references and passing objects and values and reference types and so forth everywhere in your app. In this case here, I have this local function called element at. It takes this array that I call a source, takes a position, and then it returns a reference to a certain position in this array. So what happens down here is that I'm saying, well, I want to give me the reference to the element at the first index, which is kind of the same way as saying this here, right? It's kind of odd looking at this code here and that it's not, that it's compiling and that it's all good, right? Because it looks kind of weird. And it is weird. I wouldn't want to see this in production, but this here kind of illustrates that what I'm doing here is that I'm saying, well, just give me the reference to that integer. It doesn't matter where it is. It doesn't matter if it's on the stack or the heap or wherever it is. Just give me a reference to that, and I can then set the value myself, right? It's great if you don't want to pass the references or copy values and so forth. Again, if you're kind of a game developer and you have all these, or if you work a lot with interops, you have out parameters everywhere. They've done a lot of improvements, or one improvement that's really great. So you no longer have to say, you no longer have to do this. No longer have to write this. Now what you can do is say, well, I want you to create the variable yourself if the variable was set. You know? So that's pretty cool. So you can do that in one line. I had a chat with a developer maybe a long time ago, maybe 8 years ago, and he said, well, why is there no way for you to do this? Like, it makes so much sense to just have everything on one line. And it took 10 years for them to add this to the compiler. So, I mean, must have been a really hard feature to implement. I don't know. All right, so C# 7.1. This is the first time that Microsoft did point releases. So 7.1 was one of those things that, well, why don't we call it 8? Well, maybe because there's no substantial features. We just want to add a little sugar to the language. And that's one of the things they can do with the power of Roslyn, right? They can just, when they ship an update to Visual Studio, they can also just add some language features that no one really maybe knows about. So C# 7.1, we finally got a way for us to say that we have an asynchronous main method. This means that if you write console apps that consume things that are in a database or on the web, you don't have to wrap that in a task.run and then do .wait, because that's just horrible. And if anyone's looking at that code, they will be like, whoa, this is going to deadlock. Console apps don't really deadlock, but they probably would say that. With the default expression, which is another way for us to just save a few characters, we can infer the tuple names, pattern matching with generics, ref assemblies, and let's just look at 2 of them. Because 7.1, minor release, Didn't add too many cool things. So what we have here is we have this main method here. I've marked that as an async method, and it's returning a task, and it just works as a normal console app. So if I run this, it'll delay the console for, come on. It'll delay for 1 second, and then say, wow, and then it's done. So don't need any weird things in here. It just works out of the box if we turn on 7.1, which would probably be default now. And this here is the new default keyword. Previously, you had to say, well, I want the default of shape, which would be returning null, right? But now, kind of that's redundant to say, well, I have the type here, just give me the default of that type. They can just infer that instead. Kind of makes sense. All right? And then, of course, we can infer the tuple names. We talked about this before. I kind of sneak peeked into this in the previous demo because I had bumped up the language version. So you can actually go into the project and to the CS project and change the language version that you want to support. So let me see if I can just show you that. So you can say here, well, I want to use language version 7.2 or the latest. And that'll just use the latest you have installed, which is kind of nice. But one of the things that they're doing with the compilers is, right, they're changing behavior to things that compile. And maybe there's a breaking change, and you're not ready to jump on to the next version of C#. So let's just, we don't need to jump into the PowerPoint. Let's just jump into Visual Studio and look at the additions to 7.2. Because there's not a lot. So another point release, they added ref read-only and in parameters. So again, this is one of those things that if you work with high-performance applications or games or a lot of interop, you might want to do this. So what we're doing here is that we are saying that, well, I want to return a read-only reference. So you get a reference to that particular object, which is super quick to return from that method, but you can't change it. References have always been able to be modified in the past, but now you can say, well, I want to return a read-only reference. And together with that, we get this thing called the in parameter, which kind of restricts us to what we can do with that. It's kind of the same thing as a read-only reference. So what happens here is that, well, I want to get a parameter passed into this method as a reference, and you're not able to change it. So if I try to set y to something here, it'll just break and say, well, you're not really supposed to do that. It'll tell us that you can't assign that because it's read-only. Okay? And the in here, if you're calling this method, the in keyword is kind of redundant. You still need to pass it as a reference if you do ref x here. But when you're using the in keyword, it's kind of redundant to say, well, this is a read-only thing. You can just trust them here. It kind of makes more sense when you pass it as a reference because then you're saying, well, anyone can change this value, which is kind of dangerous in some cases. One of the other changes they did in 7.2 is that they now allow us to do non-trailing named arguments, which, just get rid of this here. You'll see that I have x:ref x here, right? And previously, you'd have to say, well, y is equal to 10, for instance. But now you don't have to do that if you follow those parameters after the first one, right? Kind of nice. Another thing they introduced in 7.2 and in .NET Core, I believe, 2.1, is the ability to use spans. Does everyone know what span is? Or does anyone know what a span is? Oh, not a lot. That's awesome. So a span allows us to look at a set of memory. Think of it as just saying, well, just allow me to look at this thing here on the stack or the heap. So in this case here, I'm saying, well, I have an array of integers that I initialize on my stack. So this is also an introduction in 7.2 where they say, well, you can now use stack alloc without marking this as unsafe. So previously, you had to mark your code as unsafe when you did this. But here I'm saying, well, I want to allocate an array of 100 integers on my stack. And the span here allows me to look at that piece of the memory. And then I can do operations on that which is super quick. I can say, well, tickets here, I want to slice that from the middle and just to the end. And this gives me a new span, as you see I do on the bottom as well. But it doesn't actually cut up the array. So when you do array.takeWhile, or when you do a substring, it just copies all the values. In this case here, you just get a reference to that particular part of memory. So it doesn't actually initialize anything more than this object here that points to that particular set of memory, which allows you to do really crazy things on high-performance operations. All right? I don't know if you've seen things added to .NET Core and to ASP.NET Core, but I know that the ASP.NET team is heavily using this to optimize memory usage and doing all kinds of crazy things in the transport and all the different memory operations. Okay? So this is kind of the current state. We're at 7.3 now. But what's next of C#? Like one of these things, they're all pretty cool. They've been added to the language over the past year or two, but there's still a long way to go to kind of get features from Kotlin and Swift, and I don't know if Java's caught up with generics yet, but I know Kotlin has generics, which is great. But there's so many good things in other programming languages that we want to bring into C# as well. So again, if we head over to GitHub, there's this language features status page where they list all the different statuses. And that's actually my face. That's my contribution to the C# compiler. So they have this page here where they list all the different language features and the status of them. You can read all the documentation about, well, how do we implement this? What's the problems if we do it different ways? They have this C# 8 or 8.0 candidate where you see that it's only 3% completed. There's a lot of open issues, 28 open issues. And that's all the features they want added to the language, right? I don't expect all of these different things being added to C# 8. But if we look at it, like we have C# 8 and 9, and we'll probably have 8.1, 8.2, 8.3, and we'll probably have more 7-pointers as well. It would be cool if they call it C# X. It's because everyone else seems to call things X when it's 10. One of these days, they're going to add ranges, which is another way for us to kind of talk about a subset of data or grab things out of, for instance, this span here. We can say, well, I want to grab a certain range, and I want a pattern that I can express this with. We're going to get async streams and enumerables, which is another way for us to work with asynchronous code in our apps. We're going to get record types. So record types is one of those things they've talked about since C# 7. I love the idea of adding record types, and we'll look at what this will look like if they do add it, but they've kind of scratched it every time they release a new version of the language, and right now I feel like they're never going to add record types, but we'll see. They're going to add default interface methods, nullable reference types, null coalescing assignment, recursive patterns, and pattern matching improvements, negated condition if statements, null conditional await, and a lot more. So this list here is kind of comprehensive, right? And there's 28 more things that you can read on GitHub about what's coming to C# 8, right? But some of the things that they're adding to the language, they do as previews. So we can have a look at, did I talk about 7.3? Sorry about that. Skip too many slides. So before we jump into 8.0, let me jump back here. This is a few really quick features. They've added tuple equality, which now allows us to say, well, I'm getting a tuple out of here, which is X and Y, and we can now compare that to two different values. So I can say, well, I have this thing here. It's not really the same tuple. It's not the same reference. It just matches the values in the tuples itself, which is kind of nice to have. Okay? I'm not sure I would ever use this, but they've kind of made constraints on generics less restrictive. So in this case here, I can say, well, I want to have a generic constraint that's an enum. Or you can have a delegate. or you can have whatever you want in here. And those constraints were not possible before. There's probably a lot of cases where you would use this. Generic types itself is really, really great. And then, of course, they've added this stack alloc initializer, because they have initializers for everything else. So stack alloc is just a way for us to just allocate things on the stack. Super handy. All right, so enough about the old stuff. Let's talk about C#8. One of the things that they're going to add is ranges. Ranges is this way for us to kind of describe that I want a subset of data. So you'll see here that I'm saying I'm allocating these numbers on my stack. And then I represent this as a span, so I just get a reference to that memory stream or that part of the memory. And then I say, well, I want to give me a slice of that memory. I want you to start at element number 5, and then just give me everything else. Okay? So if I run that, well, if I don't close it first, let's run that again. If I run this, let's see if it's the right project. Let's run that. It'll say 6, 7, 8, 9, 10. All right? So it started over here, element number 5, and then went to the end. Now, this expression here can be interesting. So I can say, well, just give me 526 or 527. I'll run that again, and of course, that should just work. Gives me 2 numbers. Or I can say, well, I want you to give me everything from the end and then -1. All right, so that's give me 6 to 9. So that's pretty handy, especially if you're working with large subsets of data. If you have this large collection of things, and you want to say, well, I want to give me the subset of the thing in the middle. This is one of the things that have been missing from Python, for instance. It's one of those things that I use a lot. You could even use it for when you initialize an array, for instance. Say, well, I want you to, or when you grab data, you say, well, I want from the start to the end-ish. And this here allows us to say that. And you can even start at the end, or you can say like that. Kind of just looks like an emoji, but it just works. All right, that's pretty cool. Since this is a preview thing, I had to install a new version of the Roslyn compiler, and I had to bring in this thing that implements a lot of weird stuff, that implements all the range stuff, but we're not going to look at that. Just want to mention that this is not in Visual Studio yet, so this is just a preview thing that they might be adding hopefully soon, because I think this is good. All right, so the ranges is great. That's a great addition to the language. Now let's see if we're all still awake. We're going to talk a little bit more about pattern matching. Pattern matching is great, and it's something that, well, it can improve a little bit. So in this case here, this kind of doesn't look like any C# code that I've ever written before. So what I'm doing here is saying, well, I'm going to return a string from this method here. I'm going to return something based on this shape. It's going to run a switch statement. So it's going to switch on the shape. If the shape is a triangle, only when T, A, and B is not equal, it's going to give that. Actually, this will match when A and B is not equal. And then they've introduced this thing called recursive patterns, which is this thing here, which is kind of a mess to explain. So what happens here is that triangle, if we look at the type itself, triangle is a shape, has A, B, and C. A shape has a point. All of these different types have specified something called a deconstruct, which is one of the things that they've made improvements to when they introduced tuples. So you can deconstruct objects. What we're simply saying here is that when you call the deconstruct, it just outs A, B, and C in point. That allows you to get a copy, right? Sort of. So what I'm doing here is I'm saying, well, give me a triangle. I want to map the values from a deconstruct to A, B, C, and then I want to map the point, because the point is the last parameter in my deconstruct. I want to map the point, but I don't care about the first value. And I want you to introduce a local variable y for the y position. Okay? Did I just lose everyone? All right, so that's kind of a mouthful, right? And then I can just match a rectangle whenever it's a rectangle. That's probably the simplest one. So if I run this here, I have a triangle without a point, which means that it'll match to this default thing down here at the bottom. Because what happens here is that there's no point, so it can't really match that because it's null, right? So it can't deconstruct that. So it'll find out that, well, you didn't set the point on the object. So if I run this, it'll say, well, there's no point in running this code unless you say that the triangle has a point as well. Now what happens is that it'll match to this thing down here, which is triangle A, B, C, and where there's a point. So if I run this again here, it'll hopefully print out those values. So that's pretty cool. Now, what happens if I say, well, A and B are equal, which isn't really that great, because it should have, they should be equal, sorry. If I do that, we'll see what happens. It says A is not equal to B. So our triangle needs to have two sides that are equally long. So if I change that back to 10, it'll then match this second one here. Okay? So of course, it matches in order as well. Now, the final one here, so they have these preview compilers that you can download. But what's funny with them is that they don't have all the features in all the different versions of these new compilers. So if you want to try ranges and recursive patterns, you download one version. And if you want to try these nullable references, you have to download another one, which kind of makes it demoing these really hard. So let's just imagine that we have this person here. I'm initializing that to a new person. I'm saying print P here. And then what happens is that, well, in this case here, it's going to say p.name.length. But I haven't set name to anything. So that's going to be a null string, right? It'll throw a null reference exception. If we look at the person implementation here, I'm saying, well, this class here is nullable. So this thing here is something they want to introduce in C#8, where you say, well, everything is by default non-nullable. But now we're saying, well, this string is nullable, which in the IDE then would say, well, p.name here can be null, so you should probably do this. So you'll get some information when you run the app. So they're trying to think about, well, how do these improvements affect people that work with these language features every day? If you just upgrade the compiler and you have squiggly things everywhere, people are going to be pretty upset. So we don't want to do that. And we don't want to do what they do in Kotlin, which is they do this for everything, which is kind of a waste of keystrokes to do two scream things. So I can't run this code here because I don't have that compiler installed. But pretty much the only addition is to have this nullable for reference types as well, or nullability. So if you remove that, it's not null. And if you haven't set it, it'll be very, it'll complain that it's not set in the constructor. So if we had this and ran this with a new compiler, it would tell me that, well, you need to say in the constructor that the name is set as well. Otherwise, it won't compile, or you can probably turn those features on and off. All right, so pretty much what they're doing is that they're making up for past mistakes. So adding null to the language is probably a mistake, depending on who you talk to. But I think it's one of those things that have broken a lot of applications out there and cost a lot of people a lot of money. So there are a few more things that they're going to try and add to the language. We talked about this null reference type here, which means that if we try to set the point, in this case, to null, it'll just blow up the application because it's not nullable. So you wouldn't be able to do that. One of the features we didn't look at is record types. Now, record types is just a way for us to kind of express ourselves in a more simple manner. So in this case here, we have this triangle, which is a shape. what if I can just say, well, this triangle requires A, B, and C to exist? And if we do that, we can get a lot of cool things generated for us. So if we introduce a record type, imagine that we got this entire class generated for us. It would generate the constructor, it would generate equality checks, it would generate the hash code, it would generate the deconstructor, as well as this thing called the with method. The idea with is that you have immutability in your applications, so you can't change any objects. So instead you say, well, give me this object with x is equal to 10, and that gives you a new reference. So you don't impact any current state. That makes sense? I think that's pretty good. But they still have a long way to work to get this to work in the, and there's a lot of things in the studio that needs to be up to date as well. Now I'm a little, I don't know, weirded out by this thing. The default interface methods. Do we have any library authors in here that do like NuGet packages? Just a few, yeah. So you've probably experienced that, well, you want to update an interface. And you add a method to that interface, and you kind of upset everyone that's using your package. So what if we can say, well, I'm going to introduce this method, which in my interface, and it has a default implementation. That means that you don't have to implement that member in your classes that implement the interface. Now, do you know why I don't like this? Because it's kind of like doing multiple inheritance. All of a sudden, you can have all these different interfaces that have all these different implementations for things, and you don't know where they're coming from. So I don't know. I'm torn between liking this and not. And of course, you could say, well, I want to get an iPoint, and you could call getPoint on that. So I don't know. It's probably a great addition, especially for library authors, because what I've seen happening as well is that they create new packages instead with the new interfaces, and people have to re-implement that as well, which is also a headache. But it's a nice addition. And then we're getting null coalescing assignment. So we're getting some improvements. So instead of having to write that, we can say, well, just initialize x if y, if it's null, right? So don't do the assignment unless it's null, which is kind of nice. But again, I think they could have just used one question mark. And then we might be getting negated condition if statements. So these features that I'm talking about now, they've been on the kind of the champions list for a long time, and they've talked about these features for a long time before. But I've seen them come off and on the approved features to the language. But I don't trust them to add these features until I see them in Visual Studio. So negated condition if statements allows us to more simply write this code here. For instance, we could say, well, if shape is not triangle, or if not shape is triangle, or unless shape is triangle. So this is kind of something that they're playing with. I don't know which one I'm liking best. I think the last one is pretty nice. Does anyone agree with me that the last one is the best? Everyone. No, I'm just kidding. Again, they're adding things to allow us to write less null reference exceptions, right? So in this case here, we can say, well, if task is not null, we want to await the task, which returns that, otherwise it returns null. But what if we can just say, well, await exclamation mark task, and that just solves that entire thing for us? Because if you try to await on something that's null, it's not really happy when you do that. So kind of wrap this up. These different language features, especially the ones that I've talked about in C#8, I can't promise that they're all coming, except the ones that we looked at in Visual Studio. They will probably add the pattern matching improvements and the tuple improvements. And the ones that we have for 7.1, 2, and 3, they're already out there, so you can play around with them as well already. And I think that the idea of them rewriting the entire compiler and doing that Roslyn project has proven to be a pretty good idea. But you know, the compiler is just one part of the entire thing. In the entire C# and VB and F# ecosystem, we also have the runtime and so forth. And if you rewrite the runtime or add things to the runtime, you have even more options what you can do with the compilers. But these are some of the features that you might have missed in C#, and I hope you've enjoyed this. And on your way out, please do leave a vote. And if you have any questions, I'm available here afterwards if you want to talk. Thank you so much.